All right, welcome to Dynamax Concepts. We're looking at finding the area of shaded regions in this video. So let us take a look at our first question. So in this question, we're looking at a square. All right, so we're looking at a square. We have 32, 32, and we have a number of circles that are actually inscribed in this square. And as you could see, based on how they are designed, they're fitted close together and they did take up all the width and the length of the square. So what we're going to do is we want to find that shaded region is a general idea. And it goes like this. So in this case, the area of the shaded region, so the area of the square can be found, it's equal to length square. The circles that we're looking at, it's definitely pi r square will give you 1, and it's going to be 16 of them. Idea. Now, let us start off by finding the area of the square. So the area of the square, we could simply just say, okay, it's going to be 32 square. Multiply 32 by itself, and we're getting some 1024 cm square. So that's the area of the square that we're looking at. Now let us start off by finding the area of one of the circle. So I'm going to look at the area of one circle first. So after I found the area of the one circle, then I could just find 16 after that. Now the area of one circle is definitely pi r square. The thing is, we need to find r. So let us analyze what's going on. So the length is 32. 4, 1, 2, 3, 4 circles. Technically, we're looking at the fact that there is a diameter, right, for each. So we actually have about 4 diameters stretching across here. So stretching across here, we're looking at 4 diameters right there. So what it means then, if I take 32 and if I divide it by 4, I'm going to get the diameter for 1, which I'm able to take that diameter and then find the radius from that. So let us look at the diameter for 1, okay? So diameter, all right, so the diameter of 1 is going to be taking 32, then we're going to divide that into 4 equal parts, and we're going to get 8. So that is suggesting that this distance is 8, and we have 8 again, we have 8 again, and then all 4 of them, okay? So one of them, the diameter is 8. Therefore, the radius is to take that diameter, divide it by 2, and we're going to get 4. So now that I have the radius, I am able to easily work out the area of the circles. So basically so let us look at this. So we're talking about pi r squared. So pi is 3.14. I'm using that. And we're going to multiply this by r squared. So pi r squared, and that's for 1. But remember that it's going to be 16 of them that we need, right? So we have 16 circles here that we need to pull out of the idea. So I'm going to multiply this by 16 to capture all of them. So let's just work it out quickly. So we're doing 3.14 times 4 times 4, and then we want to multiply that by 16. So we're getting ourselves some 800 and 3.84. And this is definitely cm square. So now we have found the area of those 16 circles and actually found the area of the square. So remember now we could go back to the original plan, right? So let us see what the original plan is. The original plan that we had is of the shaded region is that we want to find the area of the square and we want to take away the area of the 16 circles. So here it is right here. So we could just put it down here that this shaded area is equal to 1024, and we're going to subtract 803.84. Let's do that. 220.16, and that is square centimeters. So that's the area of the shaded portion in that question. Now let us take a look at the second question right here. All right, so in the second question, we still want to find this shaded region. Now, based on what we got here, we're looking at here, we did get some radius. So this is suggesting that this is what we have for 2. And then it's a circle, so that's the radius, which means that we're going to have 2 here. And then this is the same. So technically, we're looking at circles. These circles are the same. The radius is 2. What it means, though, for the bigger circle is that I'm now able to see a diameter for this, which is 8 centimeters. So what we're going to do is to find the area of that semicircle, and then we're going to subtract the area of the white piece, which would have been this smaller circle and this other smaller circle. All right, so what is the general idea? It's going to be, so we could say the shaded, or the area of shaded region, two smaller semicircles, all right? So it's the area of the semicircle, and I should put bigger semicircle here, or the biggest, all right? So we have the area of the biggest semicircle there, and then we're going to subtract the area of the 2 smaller semicircles. Now let's find the area of the biggest semicircle. It has a diameter of 8. It has a diameter of 8, but remember, we only need the radius, which is 4, okay? Half of that. So the radius is 4. So let us put it together. The area of, I'll say, the large semicircle. So that is going to equal to pi r squared, but it's going to be a half of that because it's a semicircle. So that is giving us a half times pi times r. R is 4 because the diameter is 8. So the radius is 4, and we square that. So let's put that together. All right, so we have a half times 3.14 times 4 times 4. And that's going to give us about 25.12. And the unit is cm, so centimeter square. So that's that. Now let's find the area of the semicircles. And these are 2 semicircles of the same size. So technically, they're going to end up to be a single circle. So let's just look at it. Let's write it out. We're going for the area of the 2 semicircles. And we're going to put smaller here, so we're not confused. The 2 smaller ones. So let us put it together. First, we're looking at, let's clear it up so we can look at it. You take a look at these semicircles. This is the radius, which is 2. So they are the same. So basically, we're looking at a half pi r squared, but this is for one. We're going to have to double that up because it's two of them. So basically, if you relax, take it out, you could see what's going to happen. This is what we have, right? So we actually have this is for one, and it's two of them, right? And then what happened is these could cancel. As you could see, they're canceling on us. So we're left with just pi r squared. So it's going to be pi r is 2 because it's this square. So we're looking at 3.14 times 4. And this is giving us some 12.56 in the unit. So at the end of the day, these are the two numbers that we're looking for to help us out. So it's going to be 25.12, which is the area of the largest semicircle. And we're going to subtract the area of the two semicircles combined. And basically, we're going to get 12.156. So this is leaving us with 12.56. So that's the area of the shaded region right here. That's the final question. All right, so this problem, we're looking at two shapes. One is a parallelogram here. And the second one up here is so basically there is nothing to pluck out or to subtract. We're going to be adding these to get the total area of that gray area. So we are finding here the area of the figure. So the area of the figure will be as follows. It's going to be the area of triangle here. The notations are given. Opposite sides are parallel. We're seeing that we have that parallelogram. So what it means is that this is 12 here. Because of this is 12, this is 12 as well. So what I do have is I have the base of the triangle and then I have its perpendicular height, right? So I'm able to work out this quite easily. The formula that we're going to be using is half base times height for the area of the triangle. And for the parallelogram, it's basically base times height. And the height is always perpendicular. So you could see this 90-degree here coming here, helping us out right there. So let's put the numbers on. For the triangle, it's going to be a half times 12 times 10.4. Let's work that out. So that's basically 12 times a half times 10.4. And this is giving us some 62.4. And that's meter square. So this is for the triangle that we just did. Now for the parallelogram, it's very easy. It's basically 12 times 10.8. Because it's really base times height. And that's going to give us 129.6. Let's add that to 62.4. And finally, it's 192 square meters will be the area of the whole figure that we have right there. So that's it. Looking at the area of shaded regions as well as some compound shapes there. Thank you for watching Daily Math Concepts, and see you next time. We will be looking at some more videos. Bye-bye.